Hello and welcome to Electronics 2. So if you recall in the first episode, um, I was talking about, different rods and rubbing them with cloth and stuff. We basically worked out that, that positive, like attracts to negative, um, um, and negative repels negative, and positive repels positive. So anyway, there's either an attraction or a repulsion between these things. So the next thing we need to think about um, is sometime later um, uh, uh, a machine that could measure a machine that could measure physical force. A machine that could measure physical force um, um, between electrically charged particles was invented. So that happened. And this was a good way to sort of quantify what was actually going on and how was this in the with the sort of standard sort of scale of newtons and stuff like that. So and the findings were if two point objects. Now, a point object. I won't write this down, but a point object is is like it's like an object with no surface area. It's just like a point. It's actually a very if they were equally charged. Okay, now obviously this it's important to measure this. Measurement was calculated using sort of currents and stuff like this. If they were if they were equally charged to 1 coulomb, so this is just a measure of electrical charge. It's coulomb. If they're equally charged to 1 coulomb, um, and placed a meter apart, the physical force was basically 9,000 million newtons. So we could say so that's that 9 times 10 to the 9 newtons, and it was either attractive. Either attractive or repelling, depending on type of charge. Okay. So yeah, so you can see this is huge numbers. This so it's a series. It's seriously sort of powerful stuff. Now we recall we were speaking about a fluid. So the fluid, so the charged fluid, and I'll put it in inverted commas now because obviously it's not fluid. Charged fluid was found to be composed of tiny bits of matter. Called electrons. Probably should just do that F a little better. Okay, so yeah, so we're at the stage now. We're going to go into more sort of more up to date now. Okay, so a brief note about this. Now, so there's three fundamental there's three fundamental particles. We've got the protons, the neutrons, and the electrons. Okay, and obviously, we know protons, positive, neutral, and negative. Okay, so yeah. Now all atoms have protons and electrons. So you can have some. I believe protium doesn't have any neutrons. So yeah, so not all have neutrons. So yeah, okay. So we just look. I want to just I might draw this in a different color actually. So we'll do a regular blue here. So if we look at let's look at carbon. So I'll do carbon. So we're going to have a proton here, here, neutron, proton. Try and get this intersect there. Try and get intersect there. Try and then we'll just do yep. Yep. So 1, 2, 3, 4, 5. That's a big one. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's right. Okay, and then we've got the electrons. So we're going to have 2 here. And then I'll just do like something like this. So yeah, and this obviously is supposed to be kind of a bit rounder than it is. It's alright though. So yeah, so we've got carbon. Let's go back to red. So we can see we've got 6 protons, 6 neutrons, and 6 electrons. Okay. And now the important thing to realise is that there's a lot of area like here. It's like empty space. So there's a lot of empty space around all these particles. In the middle of the rings and stuff like this. Okay, so there's that. Yeah, basically the protons decide the elemental identity. So, for instance, you could remove 3 protons from lead to get an atom of gold. Obviously, the forces are incredibly strong, but that's what you did to do such a thing. Yeah, and then finally, just a point about the neutrons. If neutrons are added or gained in some other fashion, um, the atom will have the same elemental identity. But mass will change. Slightly, not a huge amount. And it may acquire strange nuclear properties. Okay. I.e. like radioactivity, perhaps. So, yeah, so that's all